So hello everyone, welcome you all to this new video. So in this video, I'm going to be discussing with two of the important transistor models which you need to be knowing. Okay. So till now, I've done six videos in this module and I've covered all the important concepts. And in the previous video, I had started with the small signal operation, channelizing all the concepts and trying to bring it in the free space and try to analyze with respect to the signals which are getting adapted. Okay. So those who are new to this video, please go and watch all the previous videos. So let us get started now with the concept of two transistor models. Okay, so there are basically two transistor models which you need to be keeping in mind. One is called as T model and another one is called as pi model. Okay, what do you mean by T model and pi model? What are the parameters which are involved in this T model and pi model, and how the circuit, equivalent circuit, would be looking like, how it would be looking like, everything we are going to be discussing in this video. Okay, so stay tuned to the video till the end. Like this video now. Before you move further, subscribe to our channel. Okay, so yeah, let us get started now. To analyze the AC operation of a transistor amplifier, we need an AC equivalent circuit, okay? Or we can also be calling that AC equivalent circuit as an AC model, okay? So that AC equivalent circuit, why it is used to analyze the AC component or the AC operation which is taking place. Because till now, whatever the circuits we have discussed, right, everything are DC operated circuits, right? So in order to get to be knowing about the AC component or and how it would be working in the AC model, this AC equivalent circuit or AC model is getting introduced. Okay, so with respect to the transistor, we are having two models. One is T model and another one is pi model. So one by one, let us discuss that. So AC equivalent circuit for AC model, for a transistor that simulates how it behaves when an AC signal is present. Okay, so this is only in the presence of the AC signal, not the DC signal. Keep that in mind. So yeah, you now see here T model. The T model is also called as Eber-Small model, okay, which is shown in this figure. And that, let us get to it later. Here in this T model, what is its functioning? You see here. Here, the emitter diode of a transistor acts like an AC resistance RE dash. Okay, what do you mean by RE dash, AC emitter resistance? Already I've told you in my previous video, RE dash is equal to 25 millivolt divided by IE. Okay, you remember it, right? So that here emitter diode of a transistor is acting like a AC resistance, in this case P model. Collector diode acts as the current source IC. Since it looks like a T shape, so that's why it is called as a T model. Okay, keep this in mind. In a T model, emitter diode of the transistor is acts like a AC resistance, so that's why that would be getting replaced by the resistance. Collector diode would be getting replaced by one current source IC. Since it look like a T shape, it is called as a T model. So when an AC input signal is applied, this gives an AC base emitter VBE across the emitter base and produces the AC base current IB as shown in the figure 9.17. Okay, let's get to that later. Here, hence, looking at base, the input impedance Z in base, okay, base input impedance as shown in the figure 9.717b, it is given by this equation here. Okay, so with respect to T model, this equation you need to be knowing, that is Z in base is given by VBE divided by IB. Okay, so here both these are small letters, so that's why you should be keeping in mind this is the AC equivalent circuit. So that's why all the abbreviations you see here, everything is kept in small letters here: currents, voltages, resistances, because this is an AC equivalent model. And I've already told you in my previous video, right, whichever of the small letter components present, current, voltage, resistance, everything, if they are mentioned in small letter, those are AC components. If they are mentioned in capital letters, those are DC components. Okay, yeah. So this equation Z in base is equal to VBE divided by IB in case of a T model. Now you see the structure here. So this is one simple NPN transistor you see here with three terminals: collector, base and emitter. NPN transistor. With respect to that, current is established here. IB, that is the base current, in this direction. IC in the downward direction, collector current, and IE in the towards the ground, that is the emitter current. Okay, so the equivalent T model, as I've told you here, this here in the collector side would be replaced by the current source here, because they are mentioned here. collector diode, or in the whatever is there in the collector side, acts as the current source IC. Okay, so that's why collector side would be replaced by one current source IC. IB remains as it is, whereas in the emitter side, emitter diode is replaced as by the AC resistance RE dash. Okay, so you see here, when we replace it by the current emitter and the base current as it is, if you look it carefully, it looks like the letter T, right? So that's why it is called as a T model. Okay, so defining the input impedance Z in base for the figure 9.17 you see here. So this is the equivalent model IB, IC, RE dash, and this is the VBE component which is present in between these two terminals, that is base and emitter. Okay, so how the Z in base is given as, Z in base with respect to the base terminal would be given by VBE divided by IB. Okay, because this is the impedance we are calculating, not the resistance. So that's why this won't be coming into the picture. Whatever is present in this region, that is the VBE voltage divided by the current flowing through this terminal, that is IB. So that's why it is given by VBE divided by IB. So these two figures are clear, right, for a T model. So now let's get quickly to the one more kind of model, that is called as the pi model. Okay, what do you mean by pi model? Let us see now. So figure 9.18 shows the pi model of the transistor. Okay. So here what it does is, you see here, this model is easier to use than the T model. Okay. Most of the people prefer this model over T model because that is a bit difficult to draw. So sometimes if they ask, in the exam, most of the time they would be definitely asking to write the AC equivalent circuit of the VDB circuit, or the two supply emitter bias circuit, collector bias circuit, base bias circuit. Okay, everything for that they would be, sometimes they might be asking to draw the AC equivalent circuit. Okay, so most of them, while drawing the AC equivalent circuit, they would be preferring pi model over T model. Okay, so this model is slightly easier as compared to the T model. Okay, why? Because you see here, this model is easier to use than the T model as shown in the figure, because the input impedance is not obvious in T model. Okay, because in this case input impedance parameter is there, right? That would be only varying with respect to the emitter EC resistance. Okay, there won't be any voltages here, and with one factor of amplification factor, that is called as beta. So applying Ohm's law to the emitter diode of the figure 9.17a, we can write this equation equal to VBE is equal to IE into RE dash. Okay, since we know that Ohm's law is equal to V equal to IR, right? So V here, it is replaced by AC component voltage, and IE is the emitter AC emitter current, and this is the AC emitter resistance. Okay, so VBE is equal to IE into RE dash. So equating VBE is equal to IB into RE dash into equation 9.11, we will be having the Z in base equation, that is VBE divided by IB, whichever we have got for pi model. So simply replace VBE is equal to IE into RE dash. Okay, so with respect to the Ohm's law here, VBE is equal to IE into RE dash divided by IB. Since we know that IE is slightly equal to IC, that is collector current and emitter current, in case of DC as well as AC, it is somehow same. The foregoing equations would be getting simplified in such a way that we would be getting the final equation for Z in base would be equal to beta into RE dash. Okay, where this beta component is there, right? You see here, IE would be getting replaced by IC. So beta is equal to IE divided by IB, or IC divided by IB. Okay, so this you should be knowing. Whenever they ask what do you mean by beta, it is called as an amplification factor. It can also be written as IE divided by IB or IC divided by IB, since IE and IC are one and the same. So that's why you would be getting the Z in base equation, that is equal to, for a pi model, that is beta into RE dash. Okay, so how the pi model is getting replaced here, you see here, this is the base terminal IB, and this is the impedance, that is beta RE dash, and this is the IC collector current, and this is the emitter current. Okay, so if you compare it with the T model, so pi model would be somehow looking like this. Okay, so this was all about pi model and T model of a transistor. analyzing them in different amplifiers we are going to be seeing in the next video. Okay, so stay tuned for that. So that's all for this video, guys. We have discussed two important transistor models. One is T model and one is pi model. Please note all the figures down if you are taking a notes while simultaneously while watching the video. Practice these diagrams very well. Okay, try to understand what you mean by T, what you mean by pi model, how the structure looks like. You should be practicing by drawing it. Okay, all the equations noted down, because in the video itself, in this notes I'm highlighting all the important points. You should, why I'm highlighting, for you guys to highlight yourself. Okay, to for you it would be easier to study, so that's why I'm highlighting the points and putting boxes and underlining the important points so that you would be understanding more. Okay, so that's all for this video, guys. We'll see you in the next video. Support us, guys. Thank you.